I'm Daniel, and I'm going to talk to you about a theme that I've seen a lot today. I saw Noah talking about it earlier. I saw Rag talking about it earlier, about how gathering data can help you improve your tests. So where do I come from? I was working at Google for 4 or 5 years. I was working on the developer infrastructure team there. Our job is to make other developers more productive. We're developers making developers productive. For 2 or 3 years of that, I worked on our browser automation team. So we launch about 6 million web browsers a day to run Selenium tests. Some Windows, some Linux, some OS X. It turns out that's a hard problem. It's a hard problem on many levels, right? So we've worked on Selenium a lot. I'm a contributor to Selenium. We tried to make it a lot more stable than it used to be. We tried to add some features that we needed. We kind of had a good chunk of the ownership for a few years of it. We worked also on the things both above and below that. So the things below that, things like starting a virtual machine to run a test, or reliably starting a browser. If you're doing that 6 million times a day, 3 or 4 nines is still tens of thousands of failures. That sucks. So we were aiming for 4, maybe 5 nines reliability starting VMs, starting browsers. Things on top as well, so things to make it easier to write tests, frameworks, things to make it easier to synchronize your tests, that kind of thing. But one thing that we did a lot of is gathering data. Again, when you're operating at that kind of scale, you need data to make sure that what you're doing is working. You need people to tell you when things are going wrong, but if you wait for people to tell you when things are going wrong, you probably won't hear until it's too late. So what are some questions that we can answer with data? Some very common questions we have in browser testing, right? How can I speed up my tests? It is a universal truth that tests are always too slow. No one has ever said, damn, my test was too fast. It's also a universal truth, particularly in browser testing, that people find their tests more flaky than they want them to be. It doesn't have to be that way. Like, browser tests are not inherently flaky, but the more moving pieces you have, and the more asynchrony, and the further you get between the code you're testing and the thing that's testing it, the more flakiness you're likely to have. So these are some of the questions, and I'm basically going to spend the next hour talking about some times when we had data that it was useful, some investigations we did, some stuff we started monitoring, which maybe will give you some ideas for how you can improve your situations too. I don't have any tools. I don't have any code for you to grab. I'm not selling any products here. These are just kind of ideas, which maybe you can integrate in your workflow however kind of makes sense. So first off, what data is it that we grab? I mean, we grab a lot of data. As I said, we start 6 million browsers a day. And that's running hundreds of millions of test cases. That's a lot of things that we're running. And we keep this data and we never throw it away. So we have over a decade's worth of data for tests that we've run. The first thing that we log is an invocation ID. That's something we store. What does that mean? So every time that someone runs, so we have an open source build tool called Bazel. Every time anyone runs Bazel test, that is an invocation. That's the equivalent of Maven test or Gradle test or running PyTest or whatever. Anytime someone runs Bazel test, that's an invocation. And that gets run exactly the same, whether you're a developer on your machine, whether it's our continuous integration system because you've just submitted some code, whether it's a continuous integration system because you're about to submit some code. Every time it goes through this tool, so every time the tests ever run, we log some data. We log the code context. This is really important. So this is, what code is being tested. Maybe it's a git commit. Maybe it's a git commit plus a diff, because you have a local diff, or whatever your source code equivalent of a commit is. But it's really important that we know what code was being run, what code was being tested. It means we can see whether 2 things should have been the same and whether they weren't. It means that we can see whether things are getting better or worse as people make more or fewer changes. Knowing what code is being tested is really important. We log the run context. So this is the question of am I running this as a developer because I'm making a bunch of changes? If that's the case, then we kind of expect your tests to fail some of the time because you're making random changes, right? Some of them don't work. Maybe you've even written your test before your code and you absolutely expect it not to work. Are you running this test because you're about to, you're sending out for code review and you're about to merge it and it's a green or red for your reviewer to see whether your code is okay? We expect those to pass most of the time. It's very rare that you intentionally, offer code that doesn't work. Is the test being run because you've submitted code, you're merging it onto master, and then we never expect your code to fail, right? Like every now and then, everyone messes up, but we really expect those to pass. And those give you different expectations for what you expect tests to be doing. We log who ran them, so we can follow up if there are problems. We log whether the test passed or failed. Like this is a really easy thing, it's a really simple thing, but just tracking pass and failure rates of tests, you can do a lot of useful analyses with. We log a lot more though, so we log reruns. So there's a feature which a lot of us dislike, but unfortunately we have to live with, where you can mark a test as flaky at Google. And if your test is marked as flaky, if it fails, the tool will try rerunning it. And if it fails again, the tool will try rerunning it again. And if the test fails 3 times, then we'll tell you it failed. We'll tell you that's bad. But if the test passes on the 2nd time or the 3rd time, we'll tell you it was flaky. That's not a great feature. It means that if you introduce real failures, it takes 3 times as long for you to find out about them. It also means that people kind of ignore low-level failures. Sometimes it's the right thing to do, sometimes it's a useful kind of sticking plaster, but it's not always great. But we log that. We track how many attempts a test took to pass, because again, it's useful data for us to see. It's useful to see whether things are getting more flaky or less flaky. We log timings. So we log how long the entire test suite took to run. Then we break that down. We log how long a test took to run. And we break that down further. We log how long it took the virtual machine to start, how long it took the Selenium server to start, how long it took the browser to start. And people can add their own extra breaking down here as well. So some people also note like, hey, I have a bunch of stages of my test. I log in, I add something to a cart, I buy, track how long each of those take. I've seen once or twice people track to the level of every time I click the mouse or every time I type a key, log how long that takes. Because these can be interesting things to track, and I'll tell you some stories about when they were. We log stack traces. So we log a bunch of logs, like we log the Selenium server log, we log the server log, we log the client log, but we log a bunch of stack traces as well. And these are really useful because we can aggregate over them. When the test fails, we see the stack trace that means why. And you can do groupings. So it means that with flaky tests, for instance, we can say, hey, every now and then you see some of your tests fail. It's not always the same tests. Like it's different tests each time. But 80% of the time, it's because the login failed. Or 80% of the time, it's because this element didn't appear in the screen. And that means that even though it's different tests that are failing each time, we can do a little bit of grouping, and that's really easy to do, right? If you have a list of 100 things, you can get the 80 that are the same and the 20 that aren't. We can say, hey, if you want your tests to be less flaky, fix this. Or maybe it's not a flake. Maybe your application code is actually buggy. If you want login to fail less, fix this. So stack traces are really useful. We log a bunch of logs. We log video. We record video of every test that we run. If they pass, we probably throw the video away quite quickly, like within a week. If they fail, we keep the video for a year. Because sometimes you want to do historical checks, right? Sometimes you want to sit and go, hey, 9 months ago my test was really flaky. My test is really flaky again. Is it flaky in the same way, or is this something new? Is this a regression, or is this a new failure? And we log known failure modes. So when, for instance, a virtual machine fails to start, we note that in what we're recording in the data. When a web browser fails to start, we note that in what we're recording. And that means that as a team who are providing the infrastructure there, as the team who are kind of responsible for making sure that browsers start up properly, we can track whether things are getting better or worse and which things we need to fix. So let's start talking about some times this has been useful. So detecting flaky tests. You know, it's a very common problem, right? You probably know you have some flaky tests. You maybe have an idea for which ones are flaky. Maybe it feels like all of them. With the data, you can help find this out, right? You can say, hey, this test fails every now and then. We have a record of the last month of every test run it's had, so we can look at it and we can see when they failed and when they didn't. One thing we have at Google is a very big compute grid. You know, we have a lot of machines where we can run tests, and we have more than half of our company in one time zone. We have about 25,000 developers. About 15,000 of them are in California. That means that we have a day and a night. Like in large-scale systems, we like to think there isn't such a thing as day and night, right? Like we like to think, hey, we have users all over the world, they're always using our system. That's not true for us. We have developers in one place. We have some developers elsewhere. We have developers in one place. We have a nighttime. And at nighttime, no one really runs many tests. Everyone's kind of asleep. So we used our spare grid capacity to rerun tests. Every time a test failed, if it was for submitted code, so if it was our continuous integration system checking that something that was submitted should have worked, every time that test fails, we mark it down. And overnight, we rerun that test. If it fails, we rerun it again. And we'll rerun it up to 10 times. And if any of those pass, we know that that test was flaky. We know that that test failed, and then we saw it pass with the same code. Maybe there's a race condition, maybe it has an external dependency, like who knows, but we know it's flaky. And so we can start listing, and we can start saying, hey, this test has failed 80% of the time that it failed, it actually was flaky. This test has failed a bunch, but it points to real failures. Because we have the data of when things pass and fail, we can rerun stuff and do correlations. Because we have the data from the reruns, we can then put up a dashboard and say, this is your flakiest test. Like, we've seen proof that this test is flaky a lot. We can point people at what they should be fixing. We as a team were responsible for making sure our infrastructure worked, right? We're responsible for making sure that when you want to start a web browser, you can. When you want to click on an element, you can. And 5 or 6 years ago, we had a problem. And the problem was that people kind of dismissed all browser tests as being inherently flaky. They're like, no, we see these things fail like 30% of the time, and our code is good, so this is a waste of our time. And they weren't wrong. Like, our infrastructure was flaky. We failed to start a virtual machine like 4% of the time we tried. We failed to start a browser like 1% of the time on top of that. The Selenium server like would segfault from time to time. Like, we had some horrible stuff going on. And that's a big problem. That's a perception problem, and it's a real problem. If people think the tests are a waste of time, they're not going to pay attention to them. If the underlying infrastructure is flaky, they're right not to pay attention to them. And those are both problems. So the first thing that we did was we started measuring these sources of failure. We started measuring how often virtual machines failed to start. We started measuring how often individual browsers failed to start. We started looking for every time something looked like it could be our fault, and we wrote it down. And after a week, we looked at it and went, oh, wow, it turns out that this one problem is responsible for 80% of our issues. I guess that's what we should fix. So we fixed it. Like, it took some time, it took some effort, but we fixed it. But then we had this really useful thing. It wasn't just that we then went back to all of these people who were really disenfranchised and thought that we were kind of full of shit and told them, hey, we fixed the problem, you should pay attention now. We could draw a graph. We could draw a graph that says, you're right, there was a problem. Look at this line. This line is bad. It's much higher than it should be. Look at how the line has gone down now. We're not just telling you we fixed the problem. We can show you that the problem isn't there anymore. Because we've been recording the data, because we can draw that graph, it helps us to have that discussion with people who don't necessarily have as much faith in us as we'd like them to have. Another thing that we noticed, and this was just a weird ad hoc thing, was I happened to notice that when people in California woke up, I was based in London, and so that was late in the afternoon for me. When people in California woke up, my tests got flakier. And I wasn't very happy with this. And so I started investigating. I drew a graph. And I found out that, yes, across the last year, there was a marked effect. Between 11 a.m. California time and 1:30 p.m. California time, tests were flakier. And it turned out what we think was happening is we were slightly running too many browsers for the amount of CPU that we were allocating on our machines, which meant that things, when lots of people were trying to run tests, there was contention for that CPU, and sometimes, JavaScript doesn't deal very well with being CPU starved, or a timer doesn't quite fire in the right time, and it makes tests fail. That sucks. But we have a graph. We can see this effect. And we think that the effect is because people run a bunch of tests just before going to lunch. Because they know it's going to be slow, so they run their tests and they go for lunch. And then they get back from lunch and see that the tests failed, and they do the one thing to fix it, and then they run all their tests again. Like, synchronized effects are a problem. Like, we know from general software, like herding is a problem. So we reduced the amount of CPU, or the number of tests we were running in the same CPU, and this effect went away. We had the data, we drew the graph, we fixed it. But this data is available to everyone in the company. So if anyone in the company is curious about something weird, if anyone in the company realizes that on Thursdays their tests seem to fail more, they can look at this data, they can draw a graph, and they can see whether that's actually the case. It empowers everyone to follow up on the problems that they run into, rather than just the people who should, who are technically responsible for them. And then it gives us, as the team responsible for this stuff, a really great place too. Because if someone comes to us and says, on Thursday our tests are more flaky, we're probably going to tell them to go away. If someone comes to us and says to us, on Thursday my tests are more flaky, and look at this graph, we'll listen to them, right? Another thing that we find from time to time is one machine is bad. Right? One machine just fails tests more often than others. Maybe it has some bad RAM, maybe it has a dodgy CPU cache, maybe it's just voodoo, like who knows. But every now and then you run into this, right? You run into a machine that causes more problems than it should. Again, we log all this data. We log every test, we log the machine it ran on, we log whether it passed or failed. So we'd start getting, depending on the severity, either emails or phone calls, possibly at 3 a.m., telling us, hey, this one machine has a 30% failure rate. That's not good. It's not failing all of the tests. Like if it's failing 100% of the tests, for sure something is wrong. But failing 30% of the test is still pretty bad. It allows us to take it out of service. It allows us to hand it to the ops people to look into. It means that we can deal with the issue. But it's really disheartening, again, for people to find that their tests from time to time run and fail and have no reason for it. The fact that we write down every test, what machine it ran on, whether it passed or failed, means that we can do this analysis. We can get those alerts. It's similar to what Noah was talking about earlier, about a lot of the exciting stuff that makes you test better comes from ops or comes from InfoSec. Like, this is pretty obvious to someone whose day-to-day job is operations and finding bad machines. But it's not necessarily the obvious thing that you should set up in advance if what you're doing is running a bunch of Selenium instances. It's really useful, though. So how are some ways that we can improve our test signal? Or not really improve our test signal, but find out how we should improve our test signal. Some things we can do is try and detect and log root causes. Is it infrastructure that's failing? Like, is the VM not starting? Is it the underlying kind of server that's being tested that's failing? Were there any exceptions logged in its log? Is it a test assertion that fails? If so, is it the same test assertion that fails over time? Look for common stack traces. Look for production log entries. Maybe in the actual server being tested, it says, hey, I couldn't connect to this one service that I rely on. Maybe it says that a lot. Maybe it says that every time a test fails. You can do that kind of aggregation and that kind of correlation and that kind of detection if you have the data. You can look at correlations too. Is it the same machine that fails? Is it the time of day that things fail? Is it the CPU load? If you have an idea for something that may be a problem, you can just add it to the logging that happens, and you get these graphs for free. You get this data for free. Once you have that, that logging in place, it's really easy to have one more idea. And maybe that idea was a waste of time, but it only took you 30 seconds to add the logging. As I said, everyone complains about slow tests. They're a problem. They cause everyone pain. One time, a team was complaining that their tests were slow. We looked at them and we're like, well, you're going to have to give us more information than that if you want us to help. Like, everyone's tests are slow. Like what's going on? And eventually they took a video of their tests and they sent them over. And we looked at the video and we saw this little bar up here, waiting for facebook.com. This kind of thing you notice when you're looking for a problem. So we run our tests on our production infrastructure. So we have in our same data centers, the same machines, maybe indexing your Gmail and maybe doing deep analysis or encoding of your YouTube videos, may also be running your Selenium tests. So we lock this environment down pretty strictly. For sure, you cannot reach facebook.com from the machine that is indexing your Gmail. That would be bad. Like, people mess up, people do bad things. We don't let that happen. So we run our tests in that environment, and we think that's good, because tests should be localized, right? Tests should be hermetic. They should be small. They shouldn't rely on facebook.com being up. Like, maybe you have 1 or 2 tests that really, you need to check that facebook.com are up. But those probably aren't tests you should run on every commit, right? That's probably part of release vetting or a nightly thing. Sometimes Facebook get angry. Sometimes you denial of service things. Sometimes Facebook isn't there. It happens from time to time. So we strongly discourage people from relying on external resources in their tests. But we don't necessarily be very nice about it. So our behavior, if you try and reach the outside world, is undefined. The only defined semantic is you will not be able to. Maybe it will instantly fail. Maybe it will take 3 minutes. It depends what timeout we're waiting for. Maybe there's just something that's black holing those packets, and your TCP stack will keep retrying and retrying until it eventually gives up. So this team were complaining that the tests were slow, and they're right, their tests were really slow, and it was for no good reason. It was because they were trying to load a Facebook like button. And their test didn't try and click on the Facebook like button. They were just waiting for it to load, and it was failing. Now, all of our starting of web browsers goes through one common library. We use Selenium, we have a little wrapper around it. So I added a little instrumentation. I added a tiny little proxy that starts up, and every time you try and navigate to anywhere through the browser, hits the proxy, it logs what hostname it's trying to talk to, and then lets the connection through. I made the quick change. It's a 30-second change, right? Start proxy, add the logging, and ran all of Google's tests. About an hour or 2 later, I had a whole bunch of results that said, hey, there are a couple of different groups of things that you're trying to connect to. Most of it's localhost. Like, that's good, right? That's what we expect. A bit of it is Google production services. So a bit of it is reaching out to youtube.com or similar services, which we technically allow, because it's not the end of the world if you're talking to youtube.com from a test. Like, it's not like it's Facebook. We're not giving data outside. But it's not a good idea. Like, it's obviously not a good idea, right? What if youtube.com goes down? What if they change the format of their page? Like, it's probably going to make your test flaky in some way, or maybe you'll accidentally cause a denial of service attack. So we have localhost, we have Google services, and we have things trying to talk to the outside. And these all fail, but maybe they take a while to do so. And so we made a few changes. First off, we had this data, right? We had the data that said most tests are good, a handful do this kind of flaky behavior thing, and a small number try and do something really dumb. One of the things it meant was we could contact all the people who own that test and say, were you aware that your test is talking to youtube.com? Maybe you could stop that. It meant that for this case, for the facebook.com case, we could just turn it off. Because now we've put the proxy there, the proxy can actually make decisions. And the proxy can reject connections eagerly. And we did this, and for a small number of tests, for like 1 or 2% of our tests, it sped them up by 30%. Speeding up your tests by 30% by black holing some connections seems like a no-brainer, right? But we put the logging in place, we did the investigation. We could then put a workaround in place, but we kept that logging, right? We kept logging to see what people were trying to do. Because every now and then you see interesting patterns. Yeah, why are my tests too slow? Some people don't control their test environment as much as perhaps they could. Again, one team came to us complaining, hey, our tests are really slow. Why are our tests really slow? We're like, I don't know, what profiling have you done? Because at the end of the day, right, if your tests are too slow, the thing you need to do is profile them. Find out what the problem is, and fix that. We have data that's recorded, so we can tell them whether it's one test that's really slow or all the tests, and it turned out it was all the tests. And then we told them to go and do some profiling and come back to us if they had a problem. They came back to us and told us they'd solved their problem. Because what they were doing, it turns out, was they were starting like 8 servers at the start of their test. And one of those servers was an entire login server. Its job was to hold a database, which takes some time to set up, add some stuff to the database for valid users, authenticate someone, and a responsible way of doing authentication is using a library like bcrypt, where you have to do quite a bit of computational work to verify that a password is correct, because it helps to rate limit people who are trying to brute force things, and then give you the answer. And it turns out starting the server took like 45 seconds. And 45 seconds is a pretty slow time for a server to start anyway, right? Like, ideally, you want a server to be starting in like 10 seconds or less. It makes rollouts easier. It means that, you know, if you have to roll back, things are nice and easy. But the server was taking 45 seconds to start. And it was completely unnecessary, right? Because every one of their tests logged in and showed that they could successfully log in. You don't need to do that in every test that you're running. So we had them, well, actually, we had nothing to do with it. They stopped starting the entire login server. They injected a cookie that meant that you were authenticated already. And all of their tests got 45 seconds faster. As a result of that, though, they started thinking about this. They started caring. This had bit them once. They weren't going to let it bite them again. So they added some instrumentation. They made it so that every time their tests run, it wrote down how long each dependency took to start, and it wrote down how long the entire dependency chain took to start. And they had a graph that showed what was contributing to their tests being slow. And they had alerts set up so that if one thing started taking longer than it should, they would get an email. And it means that instead of your tests always getting a little bit slower and a little bit slower and a little bit slower and no one noticing, people started noticing. They started getting emails saying, hey, this piece of code is kind of slow. It gives them somewhere that they can start attacking if they want to speed up their tests. Just having the data means that you can do something with it if you want. So again, what are some questions we could ask if we had the data to ask why are our tests slow? Well, what's the slowest test, right? What should I start attacking first? How long does setup take? Is that a reasonable amount of time? Would parallelizing help or hurt? It's a little weird one, but sometimes parallelizing your tests makes them slower. For sure, it makes them, you know, in some cases more expensive, because you're maybe starting more machines on EC2 or whatever than you would. Sometimes parallelizing your tests can actually make them slower. You can try that out. You can find out if you record the data for how long it takes. You can do experiments and do different amounts in parallel and find out. What remote requests am I making? What are the request timings? Like, am I spending a bunch of time doing DNS queries? Am I spending a bunch of time, you know, sending data that no one's watching? How long do individual actions take? So one team had this issue where, again, they basically came to us and said, our tests are really slow. Can you help? And we told them to go profile. And they came back to us and they said, every time we call webelement.sendKeys, it takes at least 5 seconds. And we went, okay, that definitely sounds like it's our fault. Like you've come to us with some data that shows that this is probably our fault. Let's take a look. And we watched a video of their test. And it turned out that every time they were calling webelement.sendKeys, it was trying to do an entire autocomplete lookup. And it was trying to talk to several different systems to guess what they were querying in the UI. And it was taking a really long time to do so. So they would press the key C. And then it would wait for 15 seconds while it was doing, you know, a lookup for the letter C as to what they were probably trying to type. And then they pressed the key A, and it would wait for 5 more seconds. And they pressed the letter T, and it would wait for 5 more seconds. And they definitely weren't testing that every time you press a key, it does autocomplete. Like, that wasn't what their aim was. So we worked with them. We found a workaround so that it didn't do an autocomplete for every character they tried to type, and the tests got faster. You do a bit of profiling, you log some data, you find these things out. You can then, again, put checks in place in the future to make sure it doesn't happen again, because regression is bad. Why are my tests slow? Profile, you'll find out. There have been some different kinds of analysis that we've kind of talked about here. One of them is targeted trials. So what was an example of that I did? So yeah, the remote request thing. I put the proxy in place. My question was, what would happen if I stopped allowing these connections through? I put that in place. I had the data before. I got the data after. Found out that it turns out rejecting those requests helped. It was kind of a one-off thing. It also became an interesting historical analysis. So we left that logging in place. We left that monitoring in place. It started telling us, hey, in the last month, this has happened more than it did the month before. Maybe something's changed, maybe something's going on. There's also the alerting case. So that team with their slow starting dependencies, they put alerting in place to tell them when their dependencies got slow again. They were logging this data. They had a little cron job that just ran a SQL query, every night, and would send an email if the SQL query was bad. It's a really simple thing to do. If you have the data in a table somewhere, and it doesn't really matter where, if you have the data in a table somewhere, you can write a cron job to analyze it. It's quick and easy. Some of it's speculative too. Some of it, we'll just sit there and go, hey, maybe it'll be useful to me to know what host name this this test ran on. Maybe I should write that down. I don't have any questions right now, but maybe in the future it will be handy. And the more you start logging this data, the more analyses you do, the more you start getting a feel for what could probably be useful in the future. Another question you may want to ask, and I think you were asking this question earlier, is how often should I run my tests? And certainly Noah was alluding to bits of this as well earlier. If a test has never failed, is it useful to you? Maybe you should delete it. Like, what value is it providing to you? If tests exist to fail, hopefully not too often, but they exist to fail. If a test has genuinely never failed, it's not useful to you. Maybe you don't want to run it on every commit. Maybe you just run it when you release or on a nightly build. Maybe you delete it because it turns out it's testing that 1 equals 1. But if you have the full history of every time this test has ever run in every context, you can know that. If you don't have all of that history, you cannot know that. What do people do when tests fail? If a test fails for a whole day in a row and no one fixes it, again, as Noah was saying earlier, it's probably not the most useful test in the world. Maybe it is, though. I've definitely talked with teams, and I've looked at their dashboard, and I've looked at it and gone, this test fails like 80% of the time it runs. And the person has gone, yeah, it's really flaky. But 1 in 5 of those times it fails, it's pointing at a really, really, really serious problem that means that we wouldn't be charging people money when they tried to buy things. So yes, it's a really flaky test, but it's also a really useful test. And what this person was doing, pretty much it became his job to just all day look at the results of that test and work out whether anything was really broken. Because it was a really important test. That's a happy case. In a lot of cases, it's not a happy case, obviously, but it's a happier case. In a lot of cases, when a test starts failing, people just start ignoring it. I think Rad was talking earlier that sometimes that means that you turn off the test because it's not providing value and it's giving misinformation. Sometimes you fix the test. Frequently at Google, a team will have a build comp. And it will be a rotating responsibility. And it will be someone on the team's responsibility, if the build goes red, to find out why. And either to get someone to roll back a change they made because it's a bad change, or to fix a flaky test because it's a flaky test. Or one thing that teams are increasingly doing is they have 2 builds. They have 2 continuous integration builds. One of them is their stable tests. It's the tests that always, always, always work. And you're definitely not allowed to submit code if it breaks one of those tests. The other build is their slightly less stable tests, because we all have them, right? Like, we all have flaky tests. And what they do is they put things into this unstable bucket, and they still run those tests, but they don't block submit anymore. And that's a problem, because it means that tests are starting to be ignored, but we don't always have all the time to fix all of the things that we see that could be better. But at least by having someone move these tests from one bucket to the other, you're kind of consciously making that decision, and you can look at whether that test is still being flaky. You can test whether it's been fixed. Again, if you log the data for when things are flaky, you can start doing this in an automated fashion. You can have a list of tests that are good and a list of tests that are less good. You can have someone look at that list of tests that aren't so good and check whether any of them are really important. Because if they're really important, someone should probably fix them. Sometimes tests fail together. Again, if you have a lot of data, you can start doing this kind of analysis. Sometimes 2 tests are testing exactly the same thing. Sometimes one of them is really fast and one of them is really slow, but they're testing the same thing. If that's the case, then maybe we want to treat these tests specially. Maybe we don't always want to run both of them. Maybe we run the fast one much more often than we run the slow one. Again, if you have all of this data, if you can look at every time that these two tests have ever run and say, this one's only ever failed when that one failed, you can start doing that kind of automated selection. So, how often should we run tests? I don't know. Look at some data, work it out. What do you need from your data to be able to do this kind of analysis? The first thing, the most important thing, if you're only going to do one thing, the thing you should do is store it somewhere. And it doesn't really matter where. It can be a SQL database. It can be a NoSQL database. It can be a text file. It can be a giant XML log. Like, the first step, the really important thing is write it down. Even if you don't do anything with it right now, having it will mean you can do things in the future. If you have to do like a 3-hour processing job on a giant XML file, you can do that. But it's better if it's aggregatable. If it's in a SQL database, if it's in a NoSQL database, if it's in a form where you can kind of group by, you can where, you can max and min and mean and that kind of thing. Ideally, you can output graphs as well. You can get a lot more information out of your data. You need to know where it was running. You need to compare things like for like. So you need to know that if you're plotting 2 lines on a graph, those things should be similar. If you start looking at data that shouldn't kind of be compared, if you look at the amount of tests that pass on a weekend versus on a weekday, those aren't necessarily the same kinds of tests that are being run. Certainly in our experience, the people who run tests on weekends are either crazy workaholics or people who have a really big, scary change that's going to take a lot of time to test. And so they run those tests on the weekend when there's more compute resources available. Weekends aren't necessarily indicative of your normal behavior. It's important to note that when you're doing your data analysis. There are some things you need to exclude. For instance, when I was working on the browser infrastructure team, anytime I did an analysis, I would add the clause where the person running the tests isn't on my team. Because we intentionally break a lot of stuff. Like when we're updating the version of Selenium we're using, or when we're modifying Selenium to have it wait slightly longer or slightly shorter or not do some check. And then we run all of Google's tests and find out that we broke them all. Like, that's not very useful for people. It's not useful in data analysis to know that I made a change to Selenium, I broke Selenium, and that made some tests fail. Sometimes you need to know what to include and what to exclude. These are, again, things that as you start doing data analysis, you'll start kind of getting a feel for. Basically, when something bites you, you'll start ignoring it. Also, more data is always better. Like I say, even if you don't do all of that analysis right now, even if you don't use all of the data today, you probably will find a use for it in the future. But some analyses do genuinely require you to have all of the data you possibly can have. You can't say a test never failed if you don't know all the times the test ran. So again, I'll quickly run through the data that we grab. Invocations, code context, so what code is being tested. Run context, which basically comes down to, do we expect this test to pass? Who ran them so we can follow up? Whether it passed or failed, how many reruns it took. Timings. Slow tests is like far and away the biggest complaint that people have, unless your infrastructure is really flaky. Break down your timings as much as you find useful, and then break them down a little bit further. Allow other people to break them down more. Allow someone who's written a test to add the time it takes to log in to this profiling. Because if they find it useful, they don't even need to hassle you to improve their lives. Stack traces, really useful for finding common causes. Logs and video. Like, video is really, really, really useful. If you're using someone like Sauce Labs, you probably get a video for free. If you're rolling your own infrastructure, I highly recommend you record video of all your tests. Because when a test fails 1 in 1,000 times, you don't necessarily want to run that test 1,000 more times to see why it failed. Always log video. And log the things that you know go wrong. Log what happens. So what do you do with that information when you've got it? So put it in a database. Write it down. Make sure people can access it. Make it available to everyone. If there is one person who wants to improve their life, if there's one person who wants to improve their test runtime, There's one person who's really fierce about flaky tests. Help them. Like, there's no reason to hide this information from them, right? So show them. Allow them to run interactive queries so that if they have questions, they can answer them. Run interactive queries yourself, answer those questions. Draw graphs. Like, having graphs to show how things change over time is hugely useful. Set up alerts if stuff goes wrong. If you notice that something goes wrong, fix it and make sure you know if it happens again. Telling people about big changes is really useful. Telling people, hey, we reduced flakiness by 90% is really useful. It's an important conversation to have. Having the data to prove it makes that conversation easier. A lot of teams, a lot of people have problems convincing people, particularly if your testers and developers don't work so closely together. A lot of test teams have problems convincing developers to care, particularly about Selenium tests, because they get kind of flaky, they get kind of slow. If you can have that conversation, if you can show people that things are better, if you can point fingers at where the fault actually lies, that makes that conversation a lot easier. The really important thing, though, is to remember context and follow up with people. Like, you can grab all the data that you want, but if you don't have the story around why that data is happening, you're wasting your time. I can tell you that a test fails, every 5th run, but I can't tell you whether that's because it's flaky, or my infrastructure is flaky, or because the production server is buggy, or because the production server is flaky, or because genuinely we break that behavior every 3 hours. I've seen all of those things happen. Like, I've seen tests fail often because it's a piece of code that people keep breaking. You can't just look at the data in isolation. You can't say, this test failed, this test failed, this test failed, so it must be a bad test, or it must be bad infrastructure. You need to follow up. You need to have conversations with people. You need to find out how they react when things go wrong. You need to work out why things are going wrong. It's really important to have that conversation with people to get that context and to fill in that story. Because data can help you tell a story, and it can help you find a story. But it absolutely doesn't tell you the story. And in our industry, what we do is people, right? Like, the technical stuff is hard, but it's really easy compared to the people stuff. It's much easier to try and improve the flakiness of tests than it sometimes is to convince people that the tests aren't flaky anymore. It's a lot easier to say, hey, this thing passes, or to improve something so it passes, than it is to convince someone to care that it passes. So gather data and do exciting things with it. Love any questions you have. Thank you. Questions, questions, questions? Well, that makes it easier for me. Thank you very much. That said, a hand has gone up. My life is awful.
What kind of software or language you use to create the dashboards?
The question is, what kind of software or language do we use to create the dashboards? That varies. So for the dashboards that I was working on, basically I had a cron job that ran queries against the database where we stored our data. It got a bunch of data points out, and then it would draw a graph using GNU-plot or something. I know you were talking a lot about some very exciting looking tools for drawing nicer graphs. There's a whole host of tools for presenting data usefully, though. So Noah was talking about graphene and similar. Anything that you can put data into, you can get exciting data out of.
Just one more. Is there any format that when you store it, like do you store it in a JSON format, or is it just like fields, or is there any?
What format do we store it in? So at Google, we store it in protocol buffers, because at Google, we store everything in protocol buffers. And they are indexed in Google Cloud SQL tables, which means that they're really easy to look up data in the protocol buffers. Google Cloud SQL, by the way, is amazing. Like, you can pass it any data, and it will really quickly do analysis over like terabytes of the stuff. Certainly, the team I've worked on this with since Google stored things in JSON. because JSON was a thing we were comfortable with. Using things like JQ, again, that Noah was talking about earlier, is really amazing for being able to do quick analyses of JSON. And I believe it's an input format that Google Cloud SQL accepts.
I have a question. Daniel, could you please tell us a bit more about how you do you have a huge amount of tests? Did you have a huge amount of tests? So how do you differ particular areas of tests and contact proper people? Did you do it manually or some automation? Was there something like kinds of this?
Sure. So how do we find the people who are responsible for tests, and how do we kind of look at them separately? There's a few things. So one thing to note about how Google writes software is we have one big repository that has all of our code in. It's a design pattern that seems to be being called monorepo these days. And basically, people carve out a namespace in there. So for instance, if you're working on Java, every line of Java lives in the top-level Java package. And it's a package name, so Java com Google ads, or Java com Google self-driving cars, or whatever. So you put your tests in a directory in our repo that makes sense. When you create a project that runs some of those tests, you put, we record who created the project. We have a note of who gets emailed when that project fails. So we can kind of do a lookup from the files that are checked in to the people who are notified when those tests fail. We also, however, log every time anyone runs any test. So we can also tell who the people who actually run these tests are, because frankly, they're the people who probably care about them. So we have data sources that people supply when they create projects, and we can also look at our own data to see who cares about the tests. People can also do this a little bit themselves. They can add tags to tests, either to test cases they've checked in, or when they run the tests, they can supply a tag on the command line, which can be useful, again, for performing analysis. So if you run all of your smoke tests and all of your flaky tests and stuff, you can add your own kind of groupings by tags that way.
Thank you. Thank you.
What tool would I recommend to record video while running tests? So the thing that we use, which has a few advantages, is every time we run a test, it either runs in a virtual machine, and generally you can dump the output of virtual machines to FFmpeg or something, or runs in a virtual X server, in which case we can start something called X11 VNC, which will record the entire X server, all of the windows and everything that's being displayed, and again we can pass that to FFmpeg. That has a few side effects. It means that you get not just the contents of the browser, but also anything else that's happening in that X display or in that virtual machine. So if Java pops up saying, hey, I need an update, that will maybe obscure your tests. On the other hand, if the browser pops up saying there's unresponsive JavaScript, I can't do anything, it also means that you capture that. And sometimes that's the problem. I've certainly seen some people try and do things around recording canvas tags in Firefox extensions and that kind of thing, which can kind of work. But in general, I'd say start all of your tests in an isolated environment, like a virtual machine or a virtual X display, and just grab the output of that.
You mentioned that you use proxy to run test installation to make it faster on connect textbook, etc. But doesn't proxy itself make test a little bit slower? Maybe you have profiling data. How much it slows down?
Yep. So the question is, I added a proxy to speed up tests, and proxies slow down tests. Yes, technically they do, but it's all on localhost, so it doesn't make a difference. It makes a tiny difference. But at the end of the day, browser tests are generally bound by I/O anyway, trying to make network requests. And so adding a teeny tiny bit doesn't make that much of a deal. But you're right, it's something that absolutely we profile, and we make sure we're not adding much overhead. Yeah, and absolutely, if it's not localhost, it can slow it down, and that would be probably a problem. Maybe. Grab the data.
One question. What tool do you use to gather and show test result statistics to your customer, probably?
Cool.
To show the effectiveness of your tests?
Yep. So what tools do we use to show the effectiveness, to show the results? We've generally built our own. So generally, because we've had these data sources, turning data into a graph is relatively easy. So we've done that a lot and just have big graphs and then have our front ends there say, hey, if you want to restrict to just this project or just this test, you can do that. And it's generally pretty easy to write a small server that all it does is take a test name and then we'll perform a SQL query. That's a pretty small amount of code to run and then generate some graphs. Another thing, so we had, I think it started off as an intern project. Similarly, someone who did clustering of stack traces for flaky tests to try and work out what flaky tests were and what the root causes were. That again was someone just kind of writing a small server. You can probably write 50 lines of Python or 50 lines of Ruby to take in a list of tests and turn that into, do a SQL query to get the stack traces out and then turn that into a grouped set of stack traces. So it's a small amount of code, but it's fairly simple code to write. Cool. Well, thank you very much. I'll be around if anyone wants to talk more.